Hello, welcome Kutatana, just you for now, but welcome to this latest lecture in the A Star series. So what we're going to do today, we are going to have a look at some of the problems to do with shapes. Welcome Claire as well. So we're going to have a look at some of the problems to do with shapes and shapes is quite a large it's quite a large topic. It's not possible to sort of touch on everything within the hour, but we're going to touch on a few of the key areas, particularly look at circles and yeah, we're going to particularly look at circles, things to do with that, a little bit of 2D and 3D shapes. And yeah, as we've been doing, we'll look at some notes, we'll look at some past paper examples. I'll share on my screen as I always do, but if you've got any questions at any point, please don't hesitate to ask. You can either pop on your mic or put it in the messages. Either way is fine. But we are going to start today just by having a look at circles. And so circles, you're going to come across a number of different problems to do with circles. And generally, the equations to do with circles, the thing to remember, these are the equations to do with pi. And so pi is a mathematical letter. It basically means 3.14, and we use it to solve a number of problems to do with circles. But I'm just going to, before we look at area, I realise I've written area of a circle and I've changed my mind, but we're going to just have a look at a circle in general and some of the key terminology, and I'll explain which ones I think are particularly important. We've got a big diagram here of a circle, and any of this vocabulary could come up, but some of it you might just have to recognize. So say, for example, tangent, you're unlikely to get a question on. And I would say the basics, the most important, you've got circumference. And circumference, you can see it written there, but it just means round the outside. So it's like the perimeter of a circle around the outside. Then you've got the diameter, which is a line through the middle. So the thing to remember is the diameter is double the radius. So if you are given a diameter and you need the radius, you can halve it. Or if you're given the radius, you need the diameter, you can double it. Welcome as well. Then we've got other terms here. We've got the chord. You probably only need to recognize this term if anything. It's just a line, go a straight line through a circle which doesn't go through the middle is a chord. And a bit blocked off by a chord is called a segment. We will see a question later on today. It doesn't come up too often a segment, but you may have to calculate it. So we'll look at how later on. And so an arc, the way to think of an arc is a part of the circumference. So it's not the full circumference, but it's a part of it. So if you need to work out, you work out the circumference, work out part. By the way, and I should say with a segment as well, but a segment in effect is a sector minus a triangle, but we'll see that when we come to it with an example later on. And then we've got our other terms here. We've got the radius. So we mentioned the diameter is double radius. Obviously, by the same logic, the radius is half the diameter. It's a straight line which goes through the middle and goes out. So these two are in relation. And these ones you need to know when you're working out things like area and circumference of a circle. And then we've got a sector. So a sector is basically like a slice of a circle. You almost like a slice of pizza. It's from the middle to the outside. And we going to see. And so you could say for a sector that it's part of the area being all the inside of any polygon of any 2D shape. And so a sector is a part of that. Finally, we've got a tangent, which is a straight line that touches the outside. Again, you wouldn't have to calculate it in a foundation exam, but you may possibly have to recognize it. I'm going to move on in a sec, and we are going to look at the area of a circle and calculating it. Okay. We got area of a circle, and so we're going to put an example below. Calculate the area of the below circle. Okay. Welcome Tess as well. So we've got a circle here. I say as well, give your answer to 1 dp. Okay, so basically, to calculate the area of a circle, we use the following equation. And the equation is pi r squared. And what this means in effect, remembering pi is a mathematical number, it is on your calculator as well, it's a button. If you look down, it should be over the times 10x. If you've got your calculator, you see this button here. If you press shift, so the yellow button, and the times 10x, and you actually turn your calculator on, it should give you the pi sign. And so here, what it effectively means is it's pi times the radius squared. And r means the radius. I'll write that in here just to be absolutely clear. So pi multiplied by the radius squared. Okay, so the radius is just a straight line from the middle of a circle. So we've got that here, which is 3.2. So it'll be pi times 3.2 squared. But if you're thinking in terms of BODMAS or BIDMAS, the indices or the orders, whatever you want to call it, comes before multiplication. So you can do 3.2 squared or 3.2 times 3.2 first, which would give you 10.24. And then you can do 10.24 times pi, or just type it all in together. You could on your calculator as well, but 10.24 pi, and that's going to give you 32.16 or 32.2 to 1 decimal place. Remember, 1 decimal place, it means one number after the decimal you're going to keep, and if a number after that is a 5 or higher, you round up. So you get final answer here of 32.2. Okay, so we're just going to look at an example now. And this is actually a question from a past exam paper, and this is actually a non-calculator paper. So if you're given a final answer with pi, if you multiply by pi, it will normally be in the calculator paper, but you do get area of circle questions in the non-calculator paper, but it will say give your answer in terms of pi. So here we've got work out the volume of the cylinder, give your answer in terms of pi. Well, we've got two shapes here which make up are similar. So we've got we're told it's a centimetre grid, which means, for example, we've got a rectangle here, which is 5 centimetres up, because we've got 5 squares, and we've got 6 centimetres across. So the area of our rectangle, to do the area of a rectangle, you just do length times width, so it equals 5 times 6 equals 30. Equals 30. But sorry, ignore me there, I'm doing a calculation you don't actually need to do here. So if we can ignore that bit there, quickly rub it out, backtrack Google. So because we're trying to find out the volume of a cylinder, sorry, I'm thinking as if it was in terms of surface area, but in terms of working out the volume of a cylinder, so volume of a cylinder is the area of circle times the height. That's the area of a circle times the height. So we only need our 5 centimeters here. Okay, so what we need to do then, we've got our height as 5 centimeters, but we need to work out the area of our circle. Remember, area equals pi r squared. And to work out our radius, we can go to the middle and just count the squares. But if we go up here, we've got a radius of 3 cm, so it equals pi 3 squared. 3 squared, and so, well, 3 squared equals 9 pi, because 3 times 3 equals 9, so it'd be 9 times pi, or 9 is pi. So if you are asked to give an answer in terms of pi, you just need to write how many pi. So in this case it's 9 pi, but we need the volume in terms of pi, so the volume will just be, volume is like the area of a 3D shape, it's like the inside of it, so our volume equals 9 pi times our 5, and that just equals 45 pi, and that's your final answer in terms of pi. So that's what it means when it says in terms of pi, how you would go about it. All right, so we'll move on from that. We're going to move on now, and we're going to just have a quick look at the circumference of a circle. Okay. So we've got a question here. It's just find the circumference of the below circle. And here we've got a shape, we've got a circle, it's got a radius of 12 cm. We will say again, give your answer to 1 decimal place. Okay, so in regards to this, the equation for the circumference, remember circumference means around the outside, the equation for the circumference of the circle is, we'll put it below, is pi d. No, d just means the diameter. And remember the circumference, it just means round the outside. So this is what it means by the circumference. And a good thing you can remember in terms of equations, area is always in centimeters squared. So if you're struggling to remember which equation is for area, which is for circumference, area of any shape is in centimeters squared, so it's going to be the equation involving squared. Diameter is normal centimeters, so it's just going to be to do with that. Now you may see the equation written as 2 pi. It just means the same thing, because if it's 2 times the radius times pi, well, the diameter is twice the radius, so it means exactly the same thing. It doesn't matter which way you learn it. I personally think it's better to learn as pi d because it helps separate the two equations, but either way it is fine. But in this case, we can do diameter equals 2 times the radius equals 2 times 12, which is 24. So circumference equals 24 pi. So if we put that into our calculator, by the way, if you put this into your calculator and it gives you just your answer as 24 pi, it gives you answers in terms of pi, but there's a button on your calculator just above delete, which is called the SD button. You see a button with SD on it. Give me a sec. I need to get out the camera to make sure I show this on the camera. So yes, if you see here, this one which says SD, and that's all you've got to press, and it will change it to a number. I say equals 75.39 equals, and again we're going one decimal place, one number after the decimal, number after is a 9, so equals 75.4 cm to one decimal place. All right, so that's area and circumference. You could get them in terms of you could get it in terms of pi, you could get it as a straight answer either way. Now, I'm just going to put a couple of notes here. And this will lead us into our next area. We're going to calculate more specifically, but to find the area or circumference of a semicircle, we just, so like a half circle, semicircle, so half circle, we just find the area circumference as if it was a full circle and divide it by 2. And you can do the same if it's a quarter circle, you could divide by 4. The only thing I should mention now is if it was a semicircle for circumference, if circumference, remember to then add the length of the straight edge. So say if you've got a semicircle and you need to work out the perimeter, it'd probably say perimeter in that case, but perimeter, circumference, same thing. You'd work out the semicircle, which is divided by 2, and then you just add the straight edge. But we're going to look at now for in general. So that's for semicircle. For a quarter circle, you divide by 4, but we're going to look at arcs and sectors as well. Okay. Sectors and arcs. So e.g. we're going to have find the area of the below sector to one decimal place. And the thing to remember for if you're working out a sector, so as mentioned on the first screen earlier today, a sector is part of the area of a circle. So therefore, to work out the area of a sector, we just work out a fraction of the area of a full circle. I'm using like the below formula, so I'm just going to copy the formula down here. But basically, all this formula shows is, but you work out the area of a circle, and then you work out a fraction of that. So the area of a sector equals x over 360 times the area of a full circle, where x is the angle of a sector. And remembering the area of a circle is pi r squared. And the reason you should do it like that over 360, well, any circle has 360 degrees. So if our sector is 82 degrees, that means as a fraction, it's 82 360ths of the total area of the circle. It's just that size is 82 360ths of it. So if we put that in for this question, we can say area equals 82 over 360 times pi, and we've got a radius, and the radius is still as if it was a full circle. So we're like imagining this circle continues on round like this, where it's actually going off our side here. Can we bring in it? But yeah, it's as if that's what we're imagining. As if it's a full circle, which means our radius is 12, so it'll be 12 squared. Now you could do this all in the calculator once, or you could do it in a stages. First working out the area, so the area being 144 pi, and then you can use the fraction button to do times 82 over 360, or you could do divided by 360 times 82, whatever you felt more comfortable with. And so it equals 103.04 cm squared, which is just 103.021 decimal place. Now, it might feel a bit weird, by the way, when you're rounding if you put 0.0, but we can see here our first decimal is a 0, then it's lower than a 5, so we can't change it. And in this case, well, normally you don't write 0.0. In this case, the 0.0 does mean something, because someone reading this can know there were more decimal places afterwards, and otherwise the number wasn't exactly 103. Right, and then we're going to give another example here. So we're going to have find the area so finding so I should say the same as the sector relates to area, and arc is part of the circumference. Therefore, we use exactly the same formula, but in terms of the circumference. So let's give an example below, e.g. find the circumference of the below shape. Okay, so let's get one over. Give me 1 second here. Sorry, I've written find the circumference, haven't I? I apologise, by the way, my brain's a little bit all over the place. I do kind of have a bit of a migraine, but hopefully I'm making some sense. But we've got find the arc of the below shape. And so we've got here, our shape just as before, but this time, we're concerned with the arc, we're concerned with the outside. And as said, the formula works very much in the same way, except this time we are in relation to the circumference instead of being in relation to the area. So we're going to pop our equation to the side. So we've got the area arc length equals x over 360 times the circumference of a full circle, where x is the angle of a sector and the circumference of the full circle, obviously being pi d. Okay, so in this case, we've got 118 degrees. So diameter, well, again, it's imagining it's a full circle. So the radius would be 9. So our diameter would be, of course, 2 times 9, which is 18 centimeters. And so we can say our arc equals 118 over 360, and then we've got times 18 pi. Again, you could put it all in at once in your calculator, or you could do it in parts, whatever you feel more comfortable with. If you all work it out, it's going to, I haven't actually written down how many decimal places, but we can just say here, equals 18.5 cm to 1 decimal place. So you can see the logic of the arc and the sector is very, very similar. It's all to do, exactly with a relation between the two parts. But we're going to have a look as well, just at a quick past exam question. The reason we're going to do this is looking at what I would say is the trickiest part to do with circles, which is working out a segment. The segment of a circle. So we've got a question here. We have got the diagram shows a sector OPQR of a circle, center O and radius 8 centimeters. We are told OPR is a triangle, and we need to work out the area of the shaded segment PQR, and to give your answer, correct to 3 significant figures. Okay, so if you see a question like this and you've not seen it before, it understandably looks extremely challenging. I think a lot of students who get to this stage in the exam, they sort of give up before they started. But the way you work out the segment, but what we've got here is a sector with a triangle in, so the segment equals the sector, so the whole shape, minus the triangle, because the segment is the part shaded except for the triangle. And this segment, we've got a right angle here, so it's 90 degrees. So 90 degrees, if it's 90 degrees, it equals a quarter circle. If it's a quarter circle, we can just say our sector equals, well, we've got a radius of 8, so we can say pi r squared, or pi 8 squared, divided by 4, because it's a quarter circle, so, or 64 pi divided by 4. Which you can just write as for now in terms of pi, because you can do 64 divided by 4, it's going to give us 16 pi. And if ever you've got a question like this, even if it's a calculated question, what I would recommend in the midpoint, if you haven't yet finished a question, so because you don't want to round in the middle of a question, it changes your answer. So if you have a question involving pi in the middle, simply write your answer in terms of pi until the final calculation, as this is easier to put on your calculator, because you can just write, when you're doing a later calculation, you can just write 16 pi in. As 16 pi, if you worked out as a number, it would be like 50.26548246. So you don't have to type that in. It's just a lot easier to type 16 pi. So now what we've got to do, we've got to work out our area of a triangle. And so we haven't actually done these today, but the area of a triangle. Well, a triangle, remember, is half a rectangle. In this case, to the same length, it's half a square. So the area of a triangle is simply the length times width, or really it's base times height. It might be written as base times perpendicular height straight up divided by 2. So in this case, we've got 8 times 8 over 2, which is going to 8 to 64 equals 32. And therefore, we can just do our final calculator. We can put in our calculator. So our segment equals 16 pi minus 32. So again, we can use our pi button to shift and hit. So I'm going to type that in. And then just do take 32. If we do that, it's asked us to give our answers 3 significant figures because it equals 18.265. Remember, 3 significant figures is 3 numbers after the first, from the first number bigger than 0. So it would be 1, so our first number bigger than 0, so our third would be 2. The number after it's a 6, it's a 5 or higher, so it equals 18.3 to 3 significant figures. All right, so quite a fiddly question, that one. It's got a lot of things going on with it, and that's as fiddly really as it will get in terms of a circle and foundation exam is having to work out a sector. We're going to move on to slightly different area right now. We're going to have a bit of a look at just a couple of other 2D shapes we haven't touched on. You may face in the exam. Right, so I'm not going to get too bogged down in more 2D shapes, but just one other I'm going to mention now because it does come up is one sec. We've got the area of a trapezium. Okay, so we've got a shape here, and we need to find the area of the trapezium. That's it. But a trapezium is a shape where the top and bottom are parallel. When you've got 2 diagonal lines joining up, it could be a straight line, one end of the diagonal, talk about 2 different lines joining them up. But the area of a trapezium is as follows: the area of trapezium equals half A plus B, half A plus B times the height. or times the perpendicular height. So what it means by A and B is our top and our bottom. Because in effect, what you're doing by getting halfway between them, you're trying to turn our trapezium. If you get a halfway point, it would be as if you'd turn this shape into a rectangle, and then you can just do the base times the height. This is in effect what we're doing. We're turning it in this shape, so we're cutting off half of these two bits, or unless that's not drawn to scale. So what we can do here, though, we can do 8 plus 12.5, which is going to give us 20.5 divided by 2, which is going to give us 10.25. Then we can times that by 4. Well, 0.25 times 4 gives us 1. So it's going to be 41 centimeters squared. And so that's all there is to it with a trapezium, is making sure you know that equation. I've seen it come up in maybe slightly more fiddly questions along the way, but that's the main sort of thing. And if you understand that, you should be able to solve questions to do with trapeziums. Okay, so we're going to move on now, have a little bit of a look at some 3D shapes. So we already touched on one 3D shape earlier in terms of volume, but we're just going to look at some random bits to do with it. So first of all, we are going to look at 3D shape terminology. Okay, we're going to do this with the form of a question from a past paper, and this is just testing knowledge of terminology. So we've got here, got a question, we've got the diagram shows a solid triangular prism. You need to write down the number of faces of a prism and write down the number of edges of the prism. Well, faces just means the amount of sides. And so there's a triangular prism, you've got the bottom, you've got one, you've got the side here, you've got the side there, you've got the side on the end, the other side on the end. This is difficult in a 3D shape to see where those numbers are, so I'm going to get rid of them. But you see what I mean. Every single side is one face. So a triangular prism has 2, 4, 5 faces. And then edges, write down a number of edges. It just means the straight lines. So in effect, you've got the two triangles at the end. You've got the triangle here, you've got the triangle on the other side, so that's 6 straight lines, and you've got the 3 lines joining them, so it would just be 9 lines, and that's it. So 2 terms useful to know for 3D shapes: faces and edges. That's what it means, sides and lines. But we're going to look at a question now, again to do with a triangular prism, but this one is going to have us thinking about volume. So obviously we saw the volume of a circular prism earlier. This here is a triangular prism, so it just means this. Often in this case our triangles are right angle triangles, but often a triangular prism is almost like a Toblerone shape. But basically, to find the volume of any prism, and this would also work for cubes or cuboids. So cube is, by the way, is like a 3D square. Cuboids is a 3D rectangle. Some interesting spelling. But to find the volume of any prism, cube or cuboid, you just find the area of the 2D shape on the end and multiply it by the length. So in other words, here you would find the area of a triangle on the end and you would multiply it by the length. So area of triangular prism equals the area of the triangle times the length. So in other words, the area of the triangle is half base times height, half base times height, and then times the length. Well, in this case, we're being asked something slightly different. We've been told the volume. Sorry, I realise I've written area there again. I apologise. My head is not exactly 100% today. So we've got volume of the triangular prism equals the area of a triangle times the length. So here we've been given a volume already. And we have got the length of the shape. So we've got our equation here. And what you would do, in effect, is put on all the information you've got into the equation. So we know our volume is 750. So it's going to equal 750. We know we've got a length of 25. And we know it's going to be, we've got half 5 times, and we want to work out the height, so we can just call it 5 times h, or you could just call it 5h. We've got half 5h times 25 equals 750. Now we've just got a case, we've just got to work backwards through this equation. We've solved the equations before, so to get rid of something on one side, you do the opposite. We've got times 25, so we're going to divide by 25, and that's just going to leave us with half 5h on one side and equals, well, 750 divided by 25. 25 goes into 75 3 times, we add the 0. Well, now we need to get, we've got half 5h equals 30. So the next thing we want to do is get rid of this fraction. Well, half is like 1 divided by 2. So the opposite of that is just times by 2. If we do that, that's going to leave us with 5h equals 60. And then our final thing, we've got 5h, or 5 times h, so the opposite of that is divide by 5. And so that's just going to leave us with a final answer of h equals 12 centimetre. And that's our final answer. So if you did 5 times 12, which is 60, divided by 2 is 30, times that by 25 is going to get you to 750. So if we put our numbers into our equation at the start, we can double check it and we know we have got that correct. All right, hopefully that all makes sense. All right. And so that's the volume. So just to mention as well, you can come across surface area. So surface area equals the area of all the faces of a 3D shape added together. So surface area is measured in, I'm going to put this in a sec, the lower is measured in centimeters squared, whereas volume, which is the space on the inside, is measured in cm3. I realise I haven't put this guide up for 3 days because I don't know how to do these with my computer, but it's done like that. So you sometimes come across a question I've seen, for example, with a cube. So you may you may be given a question where you need to work from the surface area of a cube to the volume, or vice versa. So for example, you could say, e.g., a cube has a surface area of, let's say, 216 cm squared, and we need to find the volume. Find the volume. Okay, so basically you get a question like this. Well, we know there's a formula for the surface area of a cube, but really it's commonsensical because we know a cube has 6 faces. And if you ever struggle to remember that, it's like 6 sides. Think of a dice. You've got 1, 2, 3, 4, 5, 6. Well, that's a cube. Therefore, so a cube has 6 faces. So therefore, surface area equals 6 times the length squared, because it's a cube, so the length and width is the same, and so the area of a square is like the length squared, hence it's called a squared number. Just like the volume of a cube is a length cubed, hence it's called a cube number. So say you have a square is 4 centimeters, the area is 4 times 4 is 16 centimeters squared. The volume will be 4 times 4 times 4 is 64 centimeters squared. But the surface area is the area of one face times 6, because there's 6 faces, so it is 6 times the length squared. So therefore, if we're going to write out these questions, we could say, therefore, 6 length squared equals 216 centimeter. All right, and now it's just a case of reworking this, going back in the other direction. So I'm going to make that look more like an L, so it's a little less confusing. And so just like any equation, we can't get rid of a squared straight away. We need to get rid of a 6. So here we got to divide by 6 to get rid of it. Whatever you do to one side, you do to the other. Now, obviously you could do this in your head, but it's been unnecessarily fiddly, so it's better to always put out your work in. 6's into 2 doesn't go, 6's into 21 goes 3, remainder 3, 6's into 36, 6's into 36 equals 6. So that tells us, what that tells us is L squared equals 36. And then we can square root that to find our length, which means our length equals 6. So remember, to square root, it's just the opposite of squaring. So 6 squared is 36, which means the square root of 36 is 6. Now, some of you might remember from algebra, but when you've got an algebra question, you do the square root. Say if it's like x squared equals 36, and you square root, the answer would be plus minus 36, because it could be positive or negative. Well, you might be wondering why in this case it has to be positive, and the reason for that is it's impossible for a length to be a negative number. A length has to exist, therefore a length has to be a positive number, so our answer has to be 6 centimeters, it has to be positive. And therefore, now we've got that, we can just simply work out our volume. Well, volume equals, well, ironically, we're going to end up back where we start because I sillily chose 6 centimeters, but it's going to be 6 cubed. 6 cubed means 6 times 6 times 6, which is actually going to be 216, but this time centimeters cubed. Now, don't be fooled by this example. The volume in a surface area is not always going to be the same. It's only the case it will be the same if you're dealing with 6 centimeters, for example. Any other number, you're going to come to a different volume to surface area, but that's how you go about it. And if you started with a volume, you would go in the other direction. So, say if we were told, I don't know, the volume of a cube is 64 centimeters cubed, and we have to work back. We would do the cube root of 64 to get to 4, then we would do 4 times 4 to get to 16, and then we would times that by 6 to get to 80 centimeters squared. Don't worry too much about the numbers in this example. What I'm saying is you do the same process. You work backwards from wherever you were, and then once you get to the length, you can work forwards again. All right. Okay, so I'm just gonna touch on a couple more very small things just before we finish. I know we've been jumping around a little bit today. Apologies for that. It's just as I say, shapes is a big topic, so it's trying to fit in as much as possible along the way. But one element I'm going to mention, because it does come up, is a mathematical term, a couple to finish, so similar shapes. So similar, it doesn't sound like a mathematical term, it sounds really vague. How they're kind of similar, they're kind of alike, but it does actually mean something. So similar shapes are shapes that are in proportion to one another. And so as a result, similar shapes is kind of linked to things like ratios and recipes, things like that, because it's all to do with proportion. So I'm going to give an example of a question below. Right, so we've got here, source A and B are mathematically similar, and we need to find the missing side length marked X. We're going to find the missing side length. And so, in order, so as shape A and B are similar, this means the sides are in proportion to one another. Therefore, to find X, we need to find the scale factor between the two shapes. And the way to do this is to divide our bases. So we've got a base in both shapes, so we can just say scale factor equals 15 divided by 5 equals 3. And so the scale factor is in what proportion? B is 3 times bigger than 5. This tells us because 5 times 3 equals 15. So therefore, let me just scroll down a tiny bit so I can fit this in there. So therefore, X equals 3 times 3 and just equals 9 centimeters. So they're in proportion with one another. It will be the same with the hypotenuse with the long sides if we needed to work them out as well. But it's normally that's all you're going to get on a similar shaped question in the foundation exam. It's just a case of understanding that terminology. I don't tend to see question on similar shapes in the foundation go beyond that in terms of difficulty, to be honest. Okay. And you could get a question as well, just one, um, um, just one more um, question here. One more thing we're going to touch on here is congruent shape. So congruent is another term you might come across, which sounds a lot more fancy than it is. So congruent shapes. And so the term congruent simply means the same. So sometimes you may be asked which shape or shapes are congruent. You may have to tessellate them, so like spin them round, but this just means which shapes are the same. So I'm going to give an example again. So final example today. So we need to just find the congruent shapes here. We're just going to have, e.g., circle, the congruent pairs of shape. Well, here we've got two sets of congruent shapes. We don't even have to tessellate this one, but B and F are congruent. You can see they are exactly the same. They both go in the same way. Going from that. And then we've got as well, you would have to flip E upside down to do it, but E and G are in effect the same shape because you could flip E and G upside down. So we're going to circle E and G as our second set of congruent shapes. All right, so that's all. The main thing is just understanding the terminology. Congruent, it just means the same. So in terms of similar shapes and congruent shapes too, so I don't think you would have to write definitions or anything like that. It's good to understand the definition so that you seem to understand similar means in proportion and congruent means the same, but no need to write. I've never seen a question where you have to write them anyway. It's always just been to calculate them. All right, no problem at all. But I'm going to leave it there for today. So yeah, thanks a lot for you guys making it along on a Friday night. Hope you all have a brilliant weekend, and we will be back next Thursday to do whatever we are doing, to do graphs. We're doing graphs next Thursday. So again, we're in our run at the moment of long, big topics. So we'll just be fitting in quite a lot of different things, jumping around past paper questions, everything like that. But yeah, have a great weekend and see you next time. Bye bye.